Afternoon, August 1st. And we're doing another test here today, but we're doing kind of in real time. We're going to take your questions, any kind of questions you have about the weather or the tropics or anything else. We're going to talk about that. Jordan Overton is with us. He's running the controls there at Fox Weather headquarters in New York. And I'm here going to run the graphics for you, and we're going to talk about what's going on in the tropics right now. And we're doing an experiment today. For the very first time, we're streaming live to TikTok. So we're really kind of unsure how that's going to work, to tell you the truth. We know that if you're watching on Facebook or on YouTube, you can send in your questions. If you have a question you'd like to ask, please put a Q colon in front of the question, like a question about the weather or a question about the tropics or hurricanes or anything like that. If you just want to make a comment, tell us where you're watching from. We'd like to hear from you that way too, but don't put the Q in front, and we can kind of keep them separate there. Jordan can sort through them more easily. So, and if you're on TikTok, I don't know how it's going to work, so we're going to try. So maybe you're just watching. Maybe you can go ahead and type in a question. Let us know that you're watching. That would be terrific. So this is our first time on TikTok, and we're going to expand this to other platforms here this hurricane season. This equipment here that we're using, the system that we're using, we're planning to actually use this when there's any kind of a threat so that we can be in contact with you. So here we are on August the 1st, right here, of course. And if we look at the odds of some sort of storm developing, we see it goes up a little bit, but not much. The first part of August, we're really pretty much in this general lull that we have through July, but it picks up a little bit. But then when we get to the middle of August, the middle between this line here, this yellow line representing the 1st of August, and this line representing the 1st of September, go right in the middle there, and you can see the odds just ramp up dramatically. Now, the oranges here are named storms. So tropical storms are hurricanes, and the darker orange, that's hurricanes only. But you can see both of them just zoom up for the second half of August in terms of the odds of one of those developing. Indeed, if you're in South Florida, and I know a lot of my friends in South Florida are watching, Hurricane Andrew was the earliest significant hurricane, category 3 or above hurricane, to hit South Florida in the record book. There was, if you actually technically go back, there's one in 1888, but that turns out to be an error in the record book. That storm hit more like a category 1 or maybe even a strong tropical storm up by Fort Lauderdale. So the earliest one in August turns out to be Hurricane Andrew on the 24th of August in South Florida. Some other storms have hit earlier in other parts of Florida. And of course, Hurricane Cleo 1964 also hit in August, and that one came up from the south. But in any case, the odds of having a storm really pick up in the middle of August, so we're not there yet. And let's talk about where we are in terms of this hurricane season. So here we are looking at the satellite, and we can see this kind of a turning in the clouds there. That's actually a very healthy disturbance, and we've been following it all week. Came off of Africa about Monday, and we could see there was going to be a rotation in it. And initially, there was some kind of concern that it might develop up in this area up here once it got past the islands. It looks like that's not going to happen, but it is going to come through the islands, and it's going to be pretty robust. It's already started there in the extreme Northeast Caribbean, but going to come through and affecting Puerto Rico today with some real downpours. But this is going to last through the weekend before it moves on out. And what has kept it from really developing? Well, it's the dust. And look at the way the dust is curled around this system here. And the dust acts like a sponge, so it takes the moisture out of the atmosphere, so the thunderstorms can't develop, so the system can't develop. But the spin continues, so that's going to mean that some of the thunderstorms that can break through the dust are going to be kind of gusty as this thing comes on through. So look at what the model says about it, and you can see that the representation of it is really this sort of kink. You see this kind of kink in here? like that. That's the representation of that tropical wave or tropical disturbance now that is pushing in on the islands. The greens are the moisture that's left over, and there's kind of two bands of it here. Moisture that's left over after the dust did its work on what moisture came with the system. And as this moves this way, we're going to get those surges going through the islands. So here's the way it's going to play out according to the computer model. Here we are today, Friday. Now let's move ahead to tomorrow. And you can see here's one band coming through, another band. So we're going to see this in the northeastern Caribbean. Just beware and pay attention to what the National Weather Service out of San Juan is saying in terms of any potential flood threat. So because some gusty squalls are going to come with this. And then we go through the rest of the weekend. The moisture finally pulls away from the northeastern Caribbean, and then it kind of surges through South Florida. It looks like about Wednesday. I mean, this is no big deal. This is just a tropical surge, more thunderstorms and probably heavier thunderstorms than kind of an average afternoon. But of course, it can really rain in South Florida on an average day. So that takes us to Wednesday. And then when we get to the end of the week, we're going to start looking back out toward Africa and the next disturbance in line here. Now, this one is kind of interesting because once it gets up in past the islands here, somewhere in there, a number of the models, and especially those new AI models, both the Google AI model and the European Center AI model, both want to show a developing storm somewhere from the Gulf to off the southeast coast. So then we're talking 10 to 14 days from now. So it's a long way in the future, and a lot of things can change. But anyway, just to give you a heads up on that possibility. This thing spinning up here, by the way, off the southeast coast is not expected to be tropical, but a low pressure system up there, kind of like a nor'easter, is what the thinking is right now along the coast, maybe some rain and some gusty winds. So that's more of a just a local weather situation than any kind of tropical development. At least that's the current thinking. Okay, let's take a look at what's going on in the Pacific, and it still is really kind of lit up. We have these two systems over here south of Hawaii. Neither are going to bother Hawaii, except the first one did bring some strong waves to the southern coast. But now the emphasis is over here. So what's going on here is, we think, is the upper level general weather pattern that was supporting development here has now moved this way. And so the bigger support is here off Mexico. And the question is it going to keep moving? You've probably heard of the MJO. This would be the MJO plus some other supportive factors in the general atmosphere. Is it going to keep moving? So the thinking is, yes. How strong will it be over the Atlantic? Will it enhance development? The thinking is maybe, probably around the middle of August. So that's the thinking. But for now, we've got these things to watch. And the main one here is Gil. And it's a 65-mile-an-hour tropical storm right now on the way to being a hurricane, according to the National Hurricane Center. It's heading off up, though, into cooler water. Here you see the forecast from the Hurricane Center. And if you notice, the top wind forecast is forecast to be a hurricane here tomorrow morning, but then slowly diminishing so that by the time it gets up here into generally the waters near Hawaii, it's down to a 30-mile-an-hour storm and dying out. Because why? Because the water gets very cool. So it has this little window of time here of relatively warm water. Then it gets up here into the water that's in the 70s. So it's going to just slowly weaken. When it comes by Hawaii, then it'll be well to the north and probably not have a significant effect, but it will affect the trade winds a bit. The typical trade winds will be a little disrupted, probably let up for a while, and then pick up again after it goes on by. Just one other thing to mention here, and that is that the system behind this one that hasn't yet developed, this one is going to go in the same direction, generally toward Hawaii, over that cooler water. So no big threat here, just a couple of systems changing the weather in paradise, as they say, as we get into next week and late next week, actually, and into the week after for the system after that. Okay, so that's where we stand right now. Jordan, do we have any questions, or do you have any thoughts?
Yeah, so we have a lot of people joining. We have a lot of TikTok viewers coming in today.
Wow,
I'm just going to put up a couple here. First,
Okay.
This is from Facebook. We've got Eddie. Bryan from Puerto Rico, who's joining us on the stream today. I've got
Great,
some
Eddie.
folks
Thank you.
We've got a couple more coming in. Our first question today is actually coming from TikTok, and the question was, how fast is Gil currently? How fast is it moving?
How fast is it moving? All right, let's go back and take a look here. I can do it. I can do it actually here. See, I have the technology. There's the cone. So it's moving at 16 miles per hour, west northwest into that cooler water at 16 miles per hour right now. Top winds at 65. It's, you can see it kind of getting a little bit ragged there on the north side, but we'll see. It's just over the edge of the warm water right now, and but it doesn't have long to go before the water is going to get significantly cooler.
All right, great. And our next question is from Facebook. It's from Angela from Palm Beach. Anything brewing in the Atlantic?
So nothing is brewing in the Atlantic right now. The long-range computer model. So what that means really has changed a lot over the last over the last year, I guess, since we've really gotten these AI models and taken a look at them and been able to verify them on past hurricanes. We haven't had much experience with them, obviously, this year. I'm going ahead to the way this animation goes here, and then I can show you, because look in the upper left there, and you're going to see the day. So that's next Wednesday, and that's when we expect the more rain there in West Palm. But then this next disturbance out here that doesn't look like anything next Friday. So we're talking about a week from today. According to the model, it's not really doing much of anything at that point. But the long range models, especially the AI models, I went through and kind of looked at all of them before we started today. And both of these prominent AI models, one from Google and one from the European Center, or the people that put out the Euro, they also run an AI version. Both of them develop a significant storm in this general area up in here. There's a big spread on the possibilities. So the difference between these modern kinds of forecasts and the way we thought of forecasts before is now the forecasts give us a spread, a very definite spread that we could easily look at. They always sort of did, but now it's so much easier to look and see, okay, how big is the cone essentially? It's sort of a dynamic cone. Is it wide? Like, is it showing a lot of different possibilities, or is it pretty narrow, and is the model more certain what's going to happen? In this case, it's wide from the Gulf to off the southeast coast, but within those possibilities, it shows pretty significant storms, even hurricanes, as a possibility. Now, the odds of any of that happening 10 to 14 days out are small, obviously, but the possibility is raised. And, you and I and everybody else are learning in real time how reliable these long-range AI-based models are and how they compare with the regular models. The AI from Google, for example, they've done some tests on it for just the regular forecast within just a few days, and they've gained accuracy of a day or day and a half, something like that, in terms of having a 5-day forecast be about equivalent to a 3.5-day forecast. But these long-range forecasts, we really don't have experience with these. So we're all learning about this together. So that's what we're going to keep an eye on, but we're talking about, sometime around the 12th, 13th, 14th, or 15th, or something like that of August, if that happens.
All right, so next up we have Dylan, also from Facebook. Kind of goes on to what we were just talking about. Comparing 2017, he reminded how 2017 started slow and then ramped up quick.
Yes, it happens. 2004 is an example of that. In 2004, we really didn't have a storm form in the tropics until even after this date. It was into August before there was the second storm. The first storm formed way up in the North Atlantic, really was just not a tropical anything. But really the tropical season didn't get going until well into August, and then it exploded. And remember, 2004 was Charlie, Francis, Ivan, and Gene all happened in 2004. So, historically, that it happens that we have slow starts and then the season really gets going. Whether that's going to happen this year, we don't know. But this year is behaving sort of like an average season. We haven't had average seasons for a while because the last 2 years, the Atlantic was so warm, putting so much extra energy into anything that got going that skewed what was going to happen and what we thought was going to happen. This year, the Atlantic is not crazy warm. Caribbean isn't crazy warm. Things are more like an average season. So the average date for the first hurricane isn't until August 11th. So, so far we're more or less on schedule, maybe a little behind in terms of the amount of tropical energy generated, but still, within the bounds of what you might call an average season, taking the 30 years from 1991 to 2020 as an average.
Yeah, and that also goes, we got a couple of questions on TikTok of, do you think it's going to be a below average season because of the quote slow start? We got a couple of questions about that on the TikTok as well.
Well, so that's a very good question. Exactly how it's going to play out remains to be seen, but the slow start doesn't say anything about how busy the season is in the end in terms of what counts. What counts is, are we going to have hurricanes make landfall in the United States, right? Or in the islands or wherever you happen to live. That's what counts. And the fact that June and July has been relatively slow, although we did have 3 named storms, but I mean, they were marginal storms at best. That does not correlate to those, to what's going to happen later on in the season. So the answer to that is we don't know. The total number of named storms isn't important. What counts really the number of hurricanes. The more hurricanes you have, the more likely are that you have a bad situation somewhere on land.
Another from Diane on Facebook. Do you see any relationship between the Atlantic Caribbean Sargassum explosion and the storm season?
That's a really interesting question. I don't know any correlation between that. I haven't seen any study about that. The sargassum is the seaweed essentially that all over in South Florida, the beaches have been covered with it in the Caribbean, and the Bahamas, all dealing with record amounts of seaweed, and it's nasty. Makes it nasty at the beach, and the communities along the beach, along Fort Lauderdale and Miami Beach, they're out there cleaning the beach up to try and make it better for swimmers and beachgoers. Boy, it's hard because there's so much of it. The dust has an effect in that it cools the water where it's super dusty. So if you have a year that's extra dusty, you get a cooler ocean because the sun gets blocked. But in terms of the sargassum, which is in the water, I don't know. It's a very good question. Since we have this kind of record year, maybe we'll get some kind of observations to push us one way or the other.
We got to give a birthday shout out. Mr. John Ross says today is his 36th birthday.
All right, today. John. The best part of life is still to come. So feel good about that.
Another one here. Let's see, this is coming in from Facebook. We kind of talked about it a little bit. Is the dust off Africa starting to subside?
Well, that's a really good question. My good friend Michael Lowry, I usually defer to on statistical sorts of things. He's a whiz at this kind of thing. But in the analysis that he has come up with, it has indeed dramatically started to subside. But if we look at what's called GEOS 5, which is a NASA model, and here, let me go back. I can show you that what we see there. That's from GEOS 5, and it's NASA runs the analysis and presents it to us. And looking at it, and we don't get measurements here, we get just the visual, right? But looking at it, it doesn't look like any kind of record low amount of dust or anything. So anyway, Michael and I were communicating about this just yesterday, and he was going to try and understand how the various measurements of the dust might agree or disagree, or why they might disagree. So we don't know. But I can tell you that visually and by effect, it doesn't seem to be lessening dramatically. Just subjectively, it feels like there are more pockets that are not dusty. But again, that's subjective, and he's coming up with objective numbers that show it indeed fading in a dramatic way. So I'm waiting to hear back from Michael on what exactly his analysis is as he tries to match up these various ways of measuring the dust, different satellites and different mechanisms of analyzing the data from satellites to pick out these particulates in the atmosphere, essentially different frequencies that identify different size particulates. But there you see this robust dust plume. And by the way, what makes me doubt that it's dramatically down is if we look at an image, which I don't have here for you, but you can go online and look at what's called geocolor images, where they kind of fake like it's a real color picture from space. You can see this very clear area of dust over the eastern Atlantic that kind of more or less matches up with the model, but not exact. And if we look up in here, actually, up and over in there, see those clouds there? Those are very low clouds, and it's caused by the dry air aloft not allowing the clouds to grow, which is a sign of dry air and dust. And we don't just have dust, we have just drying from the high pressure over the Atlantic. So it's kind of both things going on out there right now. And try and answer the question. I'll keep working with Michael Lowry. If you're in South Florida, he's on Local 10 and serves the job that I used to have and is serving you really well. So anyway, he's a real guru of these kinds of things.
All right. This question coming in from Dave. In the last decade, Southwest Florida has seen a disproportionate number of strength of hurricanes. Has the big picture changed for Southwest Florida?
Well, that's a really good question and an interesting question about the west coast of Florida in general. Indeed, Southwest Florida, suddenly seemed to be the hurricane belt. West coast of Florida in general seemed to be the hurricane belt. And so what does that mean? And does it mean anything? My inclination is that it doesn't mean anything because we've seen periods of time, stretches of years, for instance, 1954 and 1955, even 53, in the Northeast. There was a bam, 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 in 54 and 55, 6 hurricanes, all aimed at the Northeast, and there were really big ones, including Carol was a formidable one, and Diane, and then it was Hazel that came into North Carolina, but affected the whole northeastern part of the U.S. The steering currents just were persistent in that direction. In the late 40s, up to 1950, 45, 47, 48, 49, and 50, there was a Category 4 hurricane in South Florida. And then 2 of those years, there were also Category 1s in South Florida in 47 and 48. And then you had the huge Hurricane Donna in South Florida in 1960, and Cleo in 64, and Betsy in 65. So we've had these clusters of storms over some period of years, and then they just kind of go away. And, for 27 years, there was really, there was Inez in 66, which also threatened South Florida. But after that, up to Andrew, went for years and years and years. There was really not much to talk about. David in 79, I guess you'd have to call a threat, but it stayed offshore. So, right now, the storms seem to be going to the Gulf, aimed at Louisiana, west coast of Florida, and so forth. Is that a phase? Is that some sort of realignment of the storm tracks? There's no way to know. If you had to guess, I would guess that it's just a phase. And whatever it is that causes these phases that are a combination of effects, no doubt, in terms of the circulation around the Earth, the odds are it's going to change. But the west coast of Florida has always had hurricanes. Folks from Tampa Bay, I always mention the 1848. 1848, it turns out, this year in Tampa, there was 100 degree Fahrenheit was the first time in the record book that in the official record book that goes back to 1890 that it was 100 degrees there. But 100 degrees was measured, at least reported, in 1848, which happens to be the year there were also two hurricanes, including a big category 3, 4 hurricane that put something like 15 feet of water in Tampa Bay. So, and then that was in September, and 3 weeks later in October, there was another one with another 10 feet of water in Tampa Bay, both of those more than Helene. So that was an interesting year there. There wasn't much there. There was a fort called Fort Brooke there, and there were soldiers there, and they measured things like this, and that's why we have a record. But in any case, that's it happens on the west coast of Florida. It just went through a stretch where we just didn't have much of anything.
All right, this one coming in from Aaron. Seems like hurricane season peak seems to be pushed back a couple of weeks closer to late September and into October. Most recent seasons past decades. Have you noticed this?
Well, yes, I have, and there's some reason to think that that might happen this year as well, because a couple of things going on there. One is, so the peak of the hurricane season, this peak, that this graph that we all look at and we make note there of the peak, and the peak comes around September 10th. More or less, depending on how you actually measure it. That's the peak of the date when you're most likely to have a named storm anywhere in the Atlantic, the Caribbean, or the Gulf. That's not the peak date for landfalls. That comes about a week later, because storms that form in the Atlantic have to get to land, right? So, that's why we have so many big hurricanes that occur in the teens of September, including the Great Miami Hurricane and the Long Island Express, the big New England Hurricane in 1938, and many others are in that time frame. And the other thing that has happened lately is that the La Nina, which is the phenomenon in the Pacific, so when the water in the equatorial Pacific is cool, that tends to make the upper level winds over the Atlantic more conducive for storm development. Well, that has been peaking later in the hurricane season. And therefore, we've gotten the more conducive for development conditions later in the hurricane season. So that has increased the odds of storms being stronger later in the hurricane season. Now, having said that, if you're in Florida, especially in South Florida or the west coast of Florida, your peak hurricane season is later. It is the October and September are essentially tied for the number of landfalls in the peninsula of Florida. So we really do want to think later in the season in terms of when the peak is for Florida. For Texas, it's much earlier. Once you get to October, in general, Texas hurricane season shuts off because generally storms make a curve. Actually, in your direction, they curve like that, and they curve up into the Gulf. If they go into the Gulf, and they'll be more likely in Florida. That's why Florida's odds increase in October, and Texas, they decrease. But I think the overall issue is lately it's been the La Nina's peaking later in the year, making the overall weather pattern more conducive.
All right, next question from YouTube, from DR. With all that you know of, when do you see AI or any of our traditional computer models advancing on forecast in the long term?
Well, it's a really good question because, but the issue is with this AI stuff is, as you probably know, if you use ChatGPT or Anthropic or Gemini or any of them, that they change so fast, and because it's the amount of code that they write to make these things work is so much smaller than the million lines of code or whatever it is that the European Center does to generate the Euro models, or the National Weather Service does to generate the GFS model, and the various computer models that they run. And they run models, very short-term models, to try and predict exactly where strong thunderstorms are going to be. And they run these global models like the GFS to predict what's going to happen all around the Earth and how storms are going to move and big weather systems and so forth. So these are extremely complex computer programs that are simulating the atmosphere. And so making a change and being sure that this little change you make here doesn't affect something that's way down here, and all the testing they have to do and all that is really time consuming. And so the iterations of the new models come around every year or 2 years or longer. With AI, it's a very short stack of code, relatively speaking. So you can modify it more easily, and it's so much cheaper to run, doesn't require anywhere near as much computer power. And so they can modify it, run a test over here. Oh, look, that made a difference. Boom, put that into action. And so it's happening so fast. So exactly when this is going to show up in terms of long-term credibility of the forecasts or credibility of the long-term forecasts, I don't know the answer to that, but there are interesting things that you can imagine happening. For example, Greg Haycom from Dr. Greg Haycom from the University of Washington has done interesting experiments with one of his graduate students out there that essentially what they do is they look at a short-term forecast and they say, okay, what do we have to do to the initial conditions to make the short-term forecast good, perfect, and then run those initial conditions farther out and farther out. And that seems to significantly improve the long-term forecast. So there's a lot of research being done on this, but this is our first season to actually see all this in action. So we'll see as we go through this hurricane season and how the AI models indeed are modified as we go through the season. Nothing is stationary with AI. So we're going to see here this season how well they do. And no doubt it'll be different next season. And we'll see if it indeed gets significantly better in that, especially in that 10 to 14 day time frame. That does seem like there is potential for the AI to actually work kind of amazingly well.
All right, we have a kind of a fun question. I think you'll like this one. It's from our TikTok viewers. There's been like 5 of them asking the same thing. They're talking about if two
TikTok
storms collide. I know they can. They're wondering if we have 2 storms collide, can we get a superstorm? They want to know about the superstorm. What's the take on the superstorm?
So yeah, it's a very good question actually, and it comes up on occasion. But 2 storms rotating can't collide in the sense that somehow this one plus this one equals double in some sense, because if they're equal, the winds around one are going to affect the winds around the other, and they're actually going to rotate around each other. Actually, as you look at it, they're going to rotate this way, and that's called the Fujiwara effect, and it's because 2 vortices, they can't, if they're exactly the same. Now, what very often happens, however, is that one of them is weaker than the other one, and they start rotating around, but then the weaker one gets absorbed in it. And sometimes it can enhance, it can bring more moisture into the larger one. It can sometimes even enhance the spin a bit in the larger one. But that only happens when one is significantly weaker. And this only happens when they're in enough of a radius that the circulations can interact. So we're not going to get a superstorm that way. If you think about a superstorm, Superstorm Sandy is our superstorm, right? Although some people call the great storm in March of 1993 a superstorm, although at the time we called that the storm of the century. And the superstorm, I named the superstorm Sandy actually, because I didn't want to call it post-tropical cyclone Sandy because it was still very threatening. But the superstorm idea there was that it was a giant nor'easter with kind of a hurricane embedded in the middle, and that was its very unusual structure, not unheard of structure. The perfect storm, if you've seen the movie The Perfect Storm, the Halloween storm, that one was also a superstorm kind of structure. It just wasn't as giant as Sandy. So no, that wasn't caused by systems colliding. those superstorms were caused by a kind of northern system absorbing a tropical system. In the case of the perfect storm, which was 1991. Am I remembering that right? That was Hurricane Grace. What was left of Hurricane Grace got wrapped up in a northern storm and kind of existed in the center. In the case of Sandy, it was Hurricane Sandy. What was left of it was in the center of this big nor'easter. If you remember, Sandy had a big snowstorm in the mountains on the west side. So not it wouldn't be a super hurricane kind of storm in any case if we had that kind of development, and two hurricanes can't collide. But it's a good question. I mean, I get that a lot. It's a great question.
Great question. Another one that just came into TikTok here. What causes rapid intensification in hurricanes?
Well, that's a very good question, and I wish we knew exactly. We have an understanding of the kind of conditions that cause rapid intensification, and the National Hurricane Center has much more confidence in their ability to forecast it now, and they have much more confidence in their ability to actually predict it. But so those two things go together. So because of the confidence and the ability to predict it, now they're much more likely to forecast. And in the case of Helene, for example, before it even developed, they were calling for a strong hurricane to make landfall up in North Florida. So it's just more confidence. But then there are some examples of some that have intensified in 24 hours, 60, 65 miles per hour. And Hurricane King is one that hit Miami, a little tiny hurricane that hit Miami. If you know Miami, it went over downtown, but it barely affected the airport, which is just inland. It was just this tiny little, like a big tornado. I mean, it was crazy. Ida and Umberto. Umberto was over by Texas. I think that was the Umberto by Texas, which just sprung up out of nothing. It was this crazy thing. We didn't even expect anything out of it, and it turned into a hurricane right offshore of Houston, Galveston, and northeast Texas there, or East Texas, I guess. The rest of them were all Gulf storms, obviously, in just the last few years. But exactly what caused it takes just the perfect conditions and the right mechanics inside the very detailed mechanics inside the eye of the hurricane. And that's what we don't always have the good measurement on. We can measure the environment, but not exactly what's going on inside.
All right, back to the dust a little bit. From New Orleans, MJ, has the Saharan dust always been an issue, or is it a new phenomenon?
Yes, it's always been there. I mean, they've been measuring Saharan dust for a long time, way back in the day. Joe Prospero was his name, Dr. Joe Prospero from the University of Miami, went down to Barbados, and they put up these kind of nets to try and catch the dust to do dust research way back before we had satellites. So it's always been there, and we know that the dust is important for transporting nutrients to the Amazon in South America. So it's been part of the ecosystem of the world for forever, as far as we know. It's just now we have fancy graphics like this, and we have satellites and so forth to actually measure it and show it that we didn't have in the past. Because it seems to me that this is all a modern thing too, but I know very well that it's not.
So a couple of questions from our Facebook. We haven't forgotten about our Facebook viewers as well. Let's hop over there for a minute. Here's one. Does the water temperature affect hurricane strength linearly or exponentially?
That's an interesting question. Do I know the answer to that? This gets down into the maximum potential intensity, which is at any one spot. So there's a quantity called maximum potential intensity that it takes into account the water temperature, and it also takes into account like the atmospheric profile of temperatures, because if it's colder a little bit colder aloft, then you get a bigger contrast with the ocean and the thunderstorms can grow faster. If the whole atmosphere warms, then you have less effect, although the warmer atmosphere we know will cause stronger storms. But in any case, I don't know it's a complex formula that Dr. Kerry Emanuel came up with many years ago. If Kerry were here, he could tell you because he would know the formula and whether it's a linear correlation or whether there is an exponent in there. But good question. I'll see if I can. It's a good thing that I'd like to know. So I'll try and find out, but I don't have an answer for you right now.
All right, just while we're kind of on it, we got a couple people talking about where they're from. This is Cramson. Thank you for all that you do. We have one from YouTube. Love watching new expertise. And then another one is also from Facebook, watching from Italy. So we have international viewers.
Okay, so you
here.
win the farthest away so far. Let's see.
So some good ones coming in there. Another question for you here. Name one major thing that has improved over the last 30 years, your ability to more accurately forecast hurricanes.
Well, the thing that's made the biggest difference over the last 30 years is the power of computers. We just have so much bigger computers now that can digest so much more data. Therefore, when they start to run these computer forecast models, they're running with more data and a more accurate representation of the atmosphere or a more accurate representation of the hurricane. In the case of these hurricane specific models, like what's called the HAFS-A and the HAFS-B, used to be the HWRF and so forth. So it's kind of a garbage in, garbage out thing. If you don't have good data going in, you're not going to get good forecasts. Now that we can put so much more data in, we're going to get better forecasts. But there are two stages to the forecast. One is called data assimilation, and that's where the computer, that's a totally separate thing from actually running the computer model. So the data comes in, and at the European Center in London and at the National Weather Service's computer operation and their modeling effort, they take in the data and then they assimilate it to get it all to start at a particular time. So what they want is a profile of the atmosphere starting at exactly a particular time in Eastern time. It's usually in the summertime, 8 a.m. Eastern Daylight Time and 8 p.m. Eastern Daylight Time, and then also 2 a.m. and 2 p.m. Eastern time. So you want to get the data and try and understand exactly what the atmosphere is doing at exact time. And that's a process because all the data doesn't come in exactly at that time. Some might come in at 7:30. Some might come in at 2 hours before. And then you have to modify it to what you think it should be at that particular time. So the European Center spends a lot of resources on this and spends a lot of time, computer time doing it. That's a big reason that their model is delayed from the American model. And they do a little better job than we do because they spend so much more money and time and computer power assimilating it. And then they run their computer model, starting with the initialization that they come up with from that data assimilation process. And by the way, most of the AI models use the European assimilation to run from. For instance, the Google model sits and waits for the European Center to get that initialization. Then they run the model. So then the European Center runs their AI model. And I know that I don't know about the Chinese model or in the Microsoft Aurora model AI models, which are also credible AI models, but I think they run off of the European assimilation as well, but I'm not 100% sure on that. But in any case, that process, tell me, Jordan, so I'll be sure I'm answering the question. Remind me what the question was. So started talking about data assimilation and how critical that is to the process. Do you remember exactly what the question was, Jordan?
Yeah, so let me pull it back up here. Yeah, it was basically, how is the
Oh
ability
yeah, the one thing
to,
it's improved.
yeah,
Okay.
the
Yes.
ability.
So the main thing is we have bigger computers now, so we can process more data. We can understand better what exactly the state of the atmosphere is. I mean, they get data from airplanes. They get data from all different sources that we didn't used to get data from, including the hurricane hunters. All go in to initialize the process. That's made more difference, that computer power, than anything else. But there's also been, of course, good research and understanding of what's going on in the atmosphere. That's changed too. But it's only really possible to do that because we have the more powerful computers.
So yeah, a couple more people checking in. We've got Houston, Texas. Motto checking in from here. Got Joanne from West Palm Beach.
Hi, John.
There we go. We got Hannah from North Carolina, and then also
Brevard, North Carolina. Yeah, I know it well.
yeah, and then Coral Gables, right across the street from the old Hurricane Center.
Yeah.
So
Yeah, the Hurricane Center was, well, it was in Coral Gables in a couple of places. It was on the University of Miami campus, and then it moved across the street where it was during Hurricane Andrew. And of course, that building got rocked during Andrew. And the National Hurricane Center, you could always tell where it was on that high-rise building right across from the University of Miami because it was the only office in the building on the sixth floor, I think, on the southeast corner of that building that had shutters. Bob Sheets, Dr. Bob Sheets, the director at the time, insisted they put shutters on those windows, and the rest of the offices didn't have that. But one of the windows behind the shutters actually blew out from the wind pressure when the winds gusted up over 160 miles an hour there. They were right on the northern edge of the eye wall in Hurricane Andrew.
all right, our TikTok viewers are back with another question they really want answered about the MJO. So the question is, are we entering a more favorable period in the main development region of the Atlantic with the MJO?
Not yet. So the MJO. Well, let me just bring up the Pacific map here. 1 second. Well, let's see. That's not it. Let's see this one. There we go. So the MJO, first of all, what is that? That's a phenomenon. Think of it as a pulse. That's how I usually describe it. But it's a big, slow-moving, but kind of an elephant pulse that goes around the equator. And if you think about it as a wave, at some point, it's pulling the atmosphere up. So it's encouraging thunderstorms to form. And at other times, it's pushing down on the atmosphere, think of it that way, and that's suppressing activity. So when it's in the enhancement phase or the supportive phase of thunderstorms, when it's passing over and it passes slowly, nominally it takes 40 days or plus or minus to go around the Earth. But when it's passing over it, then we tend to get more storms. So when we look at the Pacific here, if you remember, all of the sudden, Iona, and there was another one in here, Cayley actually was pronounced, popped up, suddenly south of Hawaii. It was very, very unusual to have that happen in a year that's not an El Nino year. In an El Nino year, you get much warm water out in here. And if you're going to get a bunch of storms here south of Hawaii, it's because it's that warmer water regime normally. But this year, without that, they popped up. So we were thinking, okay, we have a very supportive atmosphere that almost certainly includes the MJO in that supportive regime that's allowing these storms to develop. Well, now what's happened is what was happening here now seems to be happening over here, one storm after the other, and the models forecast even after these three more storms to form here. So it seems like this supportive atmosphere, including the MJO, is moving this way, which you would expect. It moves from west to east slowly. And if that continues, that's going to move over the Atlantic. And the thinking is that it would be over the main development region of the Atlantic, the main development region being there east of the Caribbean and east normally. Sometimes it's just east of the Caribbean, sometimes it includes the Caribbean, whatever, later into August. But, and as I said, the AI models tend to want to develop more storms in the Atlantic in general, sometime around the middle of the month and moving forward, because they go out 15 days, so we can see them at that longer time period. So is that what's happening? That the MJO, this pulse, is moving that way? Yes, it's moving that way, but we had one earlier in the year. If you remember, the Eastern Pacific exploded with activity earlier this year, and then and then it stopped, and the MJO kept coming east, but it weakened dramatically and had next to no effect in the Atlantic, very minor effect, if any at all. So is this going to do the same thing, or is it going to continue as we would normally expect, that it will indeed enhance Atlantic activity? If we had to put a time on it, we're thinking middle of August to later in August right now, but there's an open question about that, actually, exactly how that's going to play out.
Yeah, and kind of on that too, since we're kind of in the Pacific talking about Hawaii, we had a question or two from TikTok about, first of all, are these systems heading towards Hawaii, which you can answer that, but also a lot of people talking about, they just had the tsunami earlier this week, so a lot of action out there in Hawaii this week.
Yeah, a lot of, yes, a lot of excitement in Hawaii. Thankfully, the tsunami with this earthquake was nowhere near as bad as from a very similar earthquake in 1952. Just goes to show you that earthquakes, we think of them being an earthquake, right? It's like back in the day, we think of hurricanes being hurricanes. Now we know that each hurricane is quite different. And it turns out each earthquake is quite different in the way that the measurement can be the same. You can have 150-mile-an-hour hurricane, 155-mile-an-hour hurricane like Ian or Charlie are both making landfall at 150 miles an hour, but dramatically different effects because of the difference in size. Well, same thing with earthquakes. You can have even similar size earthquakes that have different effects because of the way the land moves and how it puts energy in the water. So luckily, this was not a repeat of the 1952 earthquake that happened very near the Kamchatka Peninsula in Russia, and it did a lot of damage in Hawaii. Now, these storms are all moving well south of Hawaii. The ones that are out there right now are not going to be an issue. This one and this one, if this one develops, they're all going to stay well south of the islands. No problem there. Gil looks like it's going to track north of the islands, but no matter what, it's just going to be more of a moisture surge and a kind of a kink in the trade winds coming by because the water is still quite cool. Some years recently, we've had very warm water up around the Hawaiian Islands up here, water in the 80s, and that has caused us to have some storms up that way that survived. I remember, was it Douglas and Joan recently? But that's not the case this year. This year, the water is cooler up around the islands and approaching the islands. So even if these storms, like this next one, this one right here, that the computer forecast take in the general direction of Hawaii, didn't mean to draw that right at the islands, but it would be a relatively weak system by the time it got there. But it definitely could enhance the kind of limit the trade winds, bring in moisture, and then enhance the trade winds after it goes on by.
All right. We got a question here from Susan on Facebook. We in El Nino La Nina here. Are we going to be in a direct line for a storm from Miami, Florida? I'll get the graphic pulled up for you if you want to start talking about it.
Well, yeah. So the El Nino La Nina question, we're in that neutral zone. So as you may have heard in all the discussion earlier this year about this, you have El Nino, which is when the water in the Pacific is warm, and then you have La Nina when the equatorial water southeast of Hawaii is cold. And the reason we look there is just because scientific research on all this has found a correlation between that exact box there that Jordan, I can see Jordan is bringing it up here, that area of right there. You see this box right in here. Let me see if I can, there we go. This box right in here that and there's Hawaii up there. When this is warm, it suppresses hurricanes, especially when it's very warm, and when it's very cool compared to normal, then it tends to enhance hurricane activity. Right now, you can kind of make out that it's a little cooler than warm, but it's still in what's considered the neutral range. Now, the triggering events for these water temperatures, they're generally have to do with the winds. When the winds are strong, the trade winds are enhanced, blowing from North America, from and South America to the west. That's the way the trade winds go, just like in the Atlantic. If they blow hard, it blows the warm water at the surface of the Pacific over to the other side, and the cool water comes up and you get cooler. So we had this burst of wind that brought up this cool water, and we all thought, uh-oh, we're going to have a La Nina here before we expect it. But that wind has let up. The waters have stopped cooling, so we are in the neutral range. And the forecast, there you see Jordan brought that up there. The forecast is for it to stay in that neutral range. El Nino, La Nina forecasts called ENSO is the technical name for it, but they are not absolute, and they give us a range you see, but neutral to a little bit cool. So in general, when we've seen this kind of thing in the past, it hasn't had an effect on the Atlantic season. The Atlantic season is more driven by what happens in the Atlantic and the weather pattern over the Atlantic. So that's still the expectation, although it made us nervous maybe a couple of weeks ago when we saw sudden cooling, but now that seems to have arrested.
All right. Our next kind of series of questions here. So first I want to bring up this question from Theodora. Thanks for helping family with Hurricane Andrew. They were in Homestead. And speaking of...
Sure it was crazy.
Yeah, and then
friends in
speaking of
Homestead,
that...
I made a lot of good friends in Homestead as a result of Hurricane Andrew. It's a great part of now Miami-Dade County, back then just Dade County.
And then kind of related to that, another question, this one from YouTube, do you think South Florida is prepared to handle a Great Miami storm with a similar size, takes a similar track with strength on par with Andrew?
No, there's no place that is prepared to handle something like that. Now, the good thing in South Dade, if exactly Hurricane Andrew happened again, now where you have a lot of where you had in 1992 a lot of agricultural fields, now you have townhouse after townhouse, just massive construction has gone on there, and the population of Homestead has kind of exploded. But all of that new construction is built to an extremely strong building code, and we would not expect those new buildings to be damaged like the buildings were damaged during Hurricane Andrew. You should be able to stay inside your home. All the homes come with shutters or impact glass, and the roofs are tied down in every possible way, and everything's connected to the foundation and so forth. So it's a very different place than it was in 1992 because the population of southern Miami-Dade County has just exploded. It's one of the few parts of Miami-Dade County that can grow dramatically because it had this kind of open agricultural land to be developed. So it wouldn't be the same. But on the other hand, we have many more people in more high rises right at the coast. So if we had a Hurricane Andrew or any kind of strong storm farther north in the county that affected those high rises of people in condominiums all up and down the coast. I mean, if you haven't been to Miami in recent years, it looks like Asia or something. It looks like Hong Kong, with the density of high rises being built up to 1,000 feet and higher. And even though those buildings are super strong, what we haven't had is the phenomenon of having people live in those buildings, and then there's an evacuation order and they're supposed to leave. Well, if you live along the beaches in Miami-Dade County, where would you go? Because you don't, generally folks that live there don't know the city on the other side of the bay or on the other side of I-95, which is where the evacuation zones or the sheltering facilities would be and so forth. And you may not be able to get out of town. So a lot of people might say, this building is built like a battleship. I'm going to stay here and I'm going to be safe. And yes, you will be safe. You go inside, interior building, the odds are very, very high that you're going to be fine during the storm. But then what's going to happen after the storm? Because the roads are likely to be full of debris, and you won't be able to drive if your car survives storm. If it's in a parking garage, it should survive just fine. If it's on the street, probably not. But you may be stuck in that building with no power, no water, and maybe no communications, and no ability to leave. So we haven't experienced that problem yet. I think one of these days we probably will, and it's going to be really, really bad. And it's the sort of the undiscussed, I think, hurricane problem. People think of pictures of Hurricane Andrew and flooding problems, and that's another thing we haven't experienced in the modern time. We haven't experienced the Harvey kind of situation since 2000, and the city has changed dramatically since 2000, where you just have neighborhoods that are flooded, widely flooded, and because in South Florida, all of South Florida, Miami-Dade, Broward County, especially, the city is essentially paved over. So if it's not, it's not a highway, it's a street, or it's a building, or it's a parking lot. And many of those areas used to be ground to absorb the water. So now the water has to run off to get out and get away from the suburban areas. And now the tides are higher because of the changing climate. Just makes the high tide is higher. That holds the water, doesn't allow the water to drain out to Biscayne Bay and out to the ocean as quickly. So it's another thing that hasn't happened in time that most people can remember. I think 2000 was the last big flood from what was called the no-name storm at the time, and a year before that, Hurricane Irene back in 1999. So anyway, the answer is no. South Florida is not prepared. I don't think even though the building code is the best in the world, as a community, there's so many things that can still go wrong.
All right, we got time for a couple more. So here's the first one. Why do I hear experts say that the storms in a hurricane is cold cloud tops, but yet a hurricane is a warm core system?
Well, the core of the storm is warm because the air is being compressed down in the eye. And when you, if you, anybody is old enough to have an old bicycle pump that you would pump like this, and you'd feel the bottom of the pump and it would get hot because when air gets compressed, it warms up. And when air gets decompressed, it cools off. So that's why if you have some kind of like a can of compressed air and you spray it on your arm, it feels cool because it's getting decompressed, it cools off. So it's warm core in the sense that the air is warm in the center, but the thunderstorms that are growing and lifting the air around that are going up into the cooler air. And the farther up in the atmosphere they go, the colder it is. So if the cloud top reaches 20,000 feet, it's a certain temperature, 30,000 feet, it's colder, and so forth. So that's how you know how tall the thunderstorm is. It's kind of a proxy for the temperature, is kind of a proxy for the height of the thunderstorm. And the higher the thunderstorm, the more vigorous the inflow, and generally the stronger the storm, although there are other dynamics going on there. But it's two different parts of the storm is why you have those two temperature ways of discussing the temperature in the storm.
All right, our last question of the evening here, coming from TikTok. This person says, going to the Bahamas tomorrow for a week. Think any issues with that tropical wave that I need to worry about?
Well, I wouldn't worry about it. We don't see any for the next week, any kind of development, but this is a hurricane season and this is the tropical season. And just like in South Florida, you do get tropical disturbances or tropical waves that come over, and they're sort of moisture surges where you just get more thunderstorms, and you would expect that. Right now, that's happening in the northeastern Caribbean, and that's sort of coming in the direction of the Bahamas and the southern part of the Florida Peninsula, at least. So, you have to expect that in the summertime in the Bahamas. The Bahamas are blessed, depending on where exactly you are in the Bahamas. But if you're on any of the islands that face the Atlantic, the Bahamas are relatively shallow, and then between the Bahamas and Florida, you have the Gulf Stream. So all of that water really warms up. So the air that's blowing from the ocean into Florida is warm and humid. But on the other side of the Bahamas, on the Atlantic side of the Bahamas, the water is cooler, and because it gets very deep out there. And if you ever go to Harbor Island or any of the islands there, you look out and you see deep blue water. It's not that turquoisey water that you get farther east or farther west. And so you get a very nice breeze, and it's very comfortable. But anyway, the main thing is all the breeze comes off the Atlantic. So that's the way the systems come. And you got to be ready for the fact you're going to have a moisture surge if the forecasts are right coming through the Bahamas. Probably Tuesday, Wednesday-ish. Seems like right now.
All right, that does it for today.
All right, guys, this is great, and it's really exciting that we can bring in TikTok folks. As I've talked to lots of people, and we've kind of commiserated about how difficult it is in the modern world to reach people and talk to people like I was able to do, now 33 years ago with Hurricane Andrew, where it felt like we really were having a conversation with people and we're taking their calls and so forth. We've been able to do this a bit with Facebook and YouTube, but reaching young people and understanding what young people are interested in and how they're thinking about hurricane preparation and storms and so forth. We haven't been able to do that until right now. So it's great, and it's wonderful to be in communication, and this whole ability that we have here that Jordan is operating there at Fox Weather headquarters in New York, and our just ability to connect with people. And as we go, we're going to try and add this capability into other platforms so that people that read my posts or so forth on X or LinkedIn or whatever, we're going to try and expand this as much as we can for this hurricane season, so that we can communicate and understand what people are thinking and asking about if a storm does indeed threaten. So now's the time for preparation, because hurricane season is coming, and if the models are right, we'll have an increase in activity, which would coincide with the normal increase in activity sometime in the next 10 days, 14 days, something like that. Anyway, lots to watch, lots to pay attention to. And of course, we'll keep you up to date on Fox Weather, and we'll keep you up to date right here wherever you're watching us this afternoon. All right, everybody, have a good day.